We're going to continue on with adding fractions today, but in this lesson we're going to focus on the word problem aspect of it. We're going to go back to those annotation rules, so if you like using highlighters, you might want to have those out, or if you're more of an underlined person, that works for me too. So your goal for today is I will add fractions from a word problem. So let's go ahead and get started. I will say that in terms of word problems, adding and subtracting tends to be a lot easier than multiplying and dividing. So that's really good news. So how do you know it's an addition word problem? Two keywords that stick out pretty predominantly are the words altogether, total. Another one that you could look for is the word in sum. In sum, or the word sum is the answer to an addition problem. So that's a keyword as well. The word total is another one, and so just sort of keeping out for those summation rules, or those summation words rather, are really going to be helpful. And those are words that are going to point you towards knowing that addition is the operation of choice for that word problem. Just to review our annotation procedures, and remember you're going to see these throughout the entire school year with decimals, with ratios, with geometry problems, everything. I want you to go ahead and read the problem once. We're going to highlight the question in one color, and then we're going to go back, and as we reread it or re-skim it a second time, we're going to find the words that tell us the operation. Sometimes that's going to mean that we're going to highlight certain numbers or pieces of information, and then oftentimes we're going to even draw a picture. If drawing a picture is not going to help us, then we may not draw it, but oftentimes drawing a picture will help us out. All right, so we have Sophia here, and Sophia ate 3/5 of a cheese pizza. Jack ate 1/5 of a cheese pizza and 2/5 of a pepperoni pizza. How much pizza did they eat all together? So I'm going to go ahead and just grab my highlighter because I already did step 1, which was to read the problem, and step 2 is to highlight the question. So I did that. And then I need to go ahead and find my keyword. And my keyword just stuck out to me right away. And it was this word right here, all together. And so I'm also going to sort of highlight my numbers here because these numbers have to do with my operation as well, because I know I'm going to be adding those numbers up. And so I know that this word all together is going to mean addition, and I'm going to be adding all these numbers up together. So I have 3/5 plus 1/5 plus 2/5. Now, this is a pretty good situation here because they all already have the same denominator, so I can simply add straight across. So 3 plus 1 is 4, plus 2 is 6. So altogether, they ate 6/5 pizza, but in terms of pizza, I kind of like to see that in a mixed number, and so that's going to be 1 and 1/5 pizzas that they ate. All right, let's take a look at this one. Eduardo uses fabric to make 3 costumes. He uses 1/4 yard to make the first costume, 1/2 yard for the second costume, and 3/4 yard for the third costume. How much fabric did he use altogether? So step 1, I read the problem. That was pretty straightforward. Step 2, I'm going to go ahead and highlight my question. So my question is asking me how much fabric did he use. Step 3, I need to know my operation, and this word here, altogether, is telling me that I'm going to be adding up some numbers, and those numbers are 1/4, 1/2, and 3/4, because those are all the different yardages that he was working with. And one thing that I notice as I'm highlighting those is they do not all have the same denominator. So I'm going to be looking for a common denominator. So I have 1/4 plus 1/2 plus 3/4. Now this one's not too bad. So here my common denominator is going to be 4. And that should stick out to you pretty easily. 4, 2, and 4. What's the LCM? Okay. And so how many times does 4 go into 4? 1 time. So 1 times 1 is 1. How many times does 2 go into 4? 2 times. So 1 times 2 is 2. How many times does 4 go into 4? 1 time. So 3 times 1 is 3. Now I simply need to add them all up and keep the bottom the same. Sometimes students are tempted to add up the bottom as well. If you are tempted to do that, as soon as you draw that equal sign, you put that bottom right over there so that you're not tempted to add it up with it. So 1 plus 2 is 3, 3 plus 3 is 6. Now this can be simplified with a GCF of 2. So that's going to be 3 over 2. So he needs 3/2 yards of fabric, but that is also 1.5 yards of fabric as a mixed number. All right, an urban planner is designing a skateboard park. The length of the skateboard park is 1.5 feet. The length of the parking lot is 40 1/3 feet. What will be the length of the park and the parking lot combined? Okay, so I read my problem. That was step 1. Step 2 is I need to identify what my question is. And it looks like my question is they want the length of the total skateboard park in addition to the parking lot. And the word combined stuck out to me as meaning that I need to add something together. And it looks like these two numbers are going to be very important to me. So I'm going to add those two numbers together. I see that they're both mixed numbers, and so I'm going to create a WF chart for myself. Okay, and I'm going to write that out over here. 120 1/2 plus 40 1/3. There we go. All right, so I'm going to take my my whole numbers first. So 120 plus 40 is going to be 160. And then I'm going to take my fractions second. 1/2 plus 1/3. So I'm going to need a common denominator, which is going to be 6. So 2 goes into 6 3 times. So 1 times 3 is 3. 3 goes into 6 2 times, so 1 times 2 is 2, and I need more room here. All right, so 3 plus 2 is 5, and I keep my 6, and I'm going to marry the 2 together. So combined, the length is 160 5/6 feet. All right, not bad. That WF chart comes in handy. Okay, if Jody and Brian hiked the trails listed below, how far will they have hiked? So again, I'm going to highlight my question. How far will they have hiked? Okay, now what is the word that's asking me, or that is indicating my operation? Well, if Jody and Brian hiked the trails listed below, so there's no real key word here except hiked the trails listed below. And so I see 2 trails listed below here. And if there were 3 trails listed below, I'd highlight all 3. If there were 10 trails listed below, I'd highlight all 10. Either way, it seems like all of the trails listed below need to be combined together in some fashion. Okay? So again, I have some mixed numbers here. And so that tells me that I need to make a WF chart. All right, so I'm going to take my whole numbers here, so 3 plus 2, which is 5, and then I'm going to grab my fractions here, which is 2 over 3 plus 5 over 6, and it looks like I need a common denominator, and it looks like it's going to be 6. All right, so 3 goes into 6 2 times, so 2 times 2 is 4. 6 goes into 6 1 time, so 5 times 1 is 5. So let's bring it all over. So 4 plus 5 is 9 over 6. Now 9 over 6 can be simplified with a GCF of 3. So 9 divided by 3 is 3, and 6 divided by 3 is 2. Now, this is still an improper fraction, so I need to fix that into a mixed number so I can marry it with this guy over here. So that's going to be 1.5. And now I can sort of bring the two together. So 5 wholes and 1 whole is 6 whole, and then I'm going to keep the 1/2 fraction there. So they have hiked 6.5 miles. All right, Karen wakes up at 6 a.m. It takes her 1 1/4 hours to shower, get dressed, and feed the dog. It takes her half an hour to eat breakfast and make the bed. At what time will she be ready for school? Ooh, now this is where highlighting that question is important. At what time will she be ready for school? It didn't ask me how long it took her to get ready for school. It asked me what time she would be ready for school. And I'm going to like double highlight that. What time? Because once I figure how long it's going to take her to get ready, then I need to translate that into time. All right. So then where is it sort of telling me my operation? So first of all, by asking me what time, that really indicated to me that I need to add these numbers together. And so here I have 1 1/4, and here I have half an hour. And so I'm going to go ahead and work on that. And because I have a mixed number, I'm going to make myself a WF chart. So I only have one whole number over here, and then I have 1/4 plus 1/2. And I do need a common denominator, which is going to be 4. So 4 goes into 4 one time. 1 times 1 is 1. 2 goes into 4 2 times, and so 1 times 2 is 2. And then 1 plus 2 is 3, and I'm going to keep the 4 the same. And now I'm going to sort of marry these two guys together. So 1 3/4. But that's not my final answer, because now it's asking me what time will she be ready for school. So let's see. She wakes up at 6 a.m. Okay, so let's get rid of this 1 whole hour here. 1 whole hour past 6 a.m. is going to be 7 a.m. Okay, now we have 3/4 of an hour. Well, how long is an hour? It's 60 minutes. Okay, well, we're working with fourths. What's 60 minutes chopped into fourths? So what's 60 minutes divided by 4? Well, that's 15 minutes. And it's going to take her 3 of those 15 minutes. So 7:15 a.m., 7:30 a.m., and then 7:45 a.m. And that will take care of that. So at what time is she ready for school? She is ready for school at 7:45 a.m. That was a multi-part question. All right, that is the end of addition word problems. Remember, WF chart and annotation rules. Best of luck.